Here we go, 4-2, intro to functions. All right, so we have to remember what a relation is in order to get what a function is. And a function is super specific. So that's what we're going to get right now. So a function, and I got to make sure I say it right, is a special type of relation. It's a special type of relation. And there's more to it, but I want to focus on that. It's a special type of relation. Well, what's a relation again? A set of ordered pairs. So it's a special set of ordered pairs. Okay, that's what we're saying. Where, so specifically where each, and I'm going to write it a little bit differently than I did in years past, where each input value gives exactly one, and when I mean exactly one, I mean exactly one output value. And the definition will always work. If we have a debate, you know how people debate about things? A lot of times people debate is because they don't have the same definitions for words. They're like, some people say math is hard, some people say math is easy. So there's a debate. Well, I think math is hard because you got a lot to do, you got a lot of stuff to memorize, you got really complicated numbers, and the other side's saying, well, I think it's really easy because I really get it quickly. It doesn't take me long to do all that work, but there's one big issue. You haven't defined something. What do you mean by easy and what do you mean by hard? What are those definitions? Because what you think is easy, I think is not. So we could say, well, let's not use that. Math requires a lot of time for the average person. So now you have a set definition. Now we could say, yes, it does require more time for the average person or less time for the average person, whatever you're talking about. So this definition will always cover me on what a function is. Every input value gives off exactly one output value, okay? So please remember that because I'm going to keep asking over and over again. So we're going to start off with a table here. It's the one on page 96. So go ahead and reproduce it. Here we go. It's 2-column, and normally you're going to have x and y, but you can have other variables, and we're going to have 5 values. 1, 2, 3, 4, 5. Okay, then give us some nice numbers. Ooh. Okay. This is a table. It is a relation automatically. Why is it a relation? Because it shows me a set of ordered pairs. It is a set of ordered pairs. You see the ordered pair -2, 16 and the ordered pair 1, 1 and 2, 16. That is a relation. Okay, that's for sure relation. But is it a function? Before I get to that, we're going to review what is the domain of this relation so far. Relation, yep.
-2, -1, 0, 1, 2.
Awesome. All right, so -2, -1, 0, 1, 2. Okay, so that's my domain. What's my relation? And do you ever repeat values, by the way? Do you ever like rewrite them over and over again? No, just write them once for each element of the domain and range.
0, 1.
So 0, 1, and 16. Okay, good. Oh, not good. All right, so the domain and range, no issues with that. By the way, do you like tables when you are asked to get the domain and range? Yeah, I think it's super easy. It's just like read the numbers, don't repeat any of the numbers, but that's it. Okay. Is this a function? Okay. Is it a special type of relation? Well, it is a relation, but is it special in that every input value gives off only one output value? You know, like, what are you talking about input output? The x variable is the input and the y variable is the output. And do you guys remember independent, dependent variables? Do you guys remember that from science? Kinda? Well, don't worry, we'll remind you of that. Do you guys remember what independent means? What does it mean, independent variable, not just independent, like I'm by myself. What does it mean by independent variable? Yes, sir?
Is it a variable that you change?
Okay, it's a variable you can change, and that independent variable causes the dependent variable. Or you can say it this way, the dependent variable depends on the independent variable, right? That's hopefully makes sense. So your x and y. Okay, does every element or does every input value give off exactly one output value?
Yes.
I got one yes. No. Okay, I got a no. Love this question because it divides us. Okay, ready? All right, let's look at the input value -2. Does -2 only give off one output value? Yes, okay. -1, does it give off only one output value? Yes. 0, does it only give off one output value? Yes. 1, does it give off only one output value? Yes. This number only gives off 1. Does 2 give off only one output value? Yes. It is a function. Now, how many of you were thrown off by the fact that the output value 1 is repeated or 16 is repeated? Is that what you were thinking maybe? Okay, but remember what I said by my definition? Every input value gives off only exactly one output value. Can these two inputs give off the same thing?
Yes.
Yes. But each one of these, -2 and +2, give off only one thing. They can only produce one thing from that. Have you guys heard of function machines? Have you ever seen those in math back in the day? Where you put something into the machine and out comes out a number and you have a rule? That's kind of what's going on here, like a factory. You put in -2, you're going to get 16. That's it. You can't get anything else. Yep.
Do I get a fair Excel day because I said yes?
I said yes.
There's people that said yes.
There are a lot more yeses than I heard.
Can everybody get a fair?
I think everyone did get an Excel day, free Excel day. Yeah,
Can we
come
get
on.
another one?
No. I'm going to take one away is what I'm going to do by challenging you to the function game. You're all invited.
Well,
iExcel, awesome,
Sorry, I got
yes.
something this Friday. Can't make it.
Oh, don't worry, it's today.
It's the same thing as today.
Okay, it's right now actually.
Old school.
I have it every day.
All right, let's look at I like your creativity, guys.
Sorry.
Let's look at a set of ordered pairs here. We'll go with 0, 7, 1, 7, 2, 9, and 3, 16. 2, 9, and 3, 16. All right, let's see. Hagen, is that a relation? Yes, it is. Why is it a relation, Dylan? That's a relation? Really?
Hang on 1 second.
That's okay. I'm holding.
Because they're all ordered in the pairs.
Yeah, it's ordered pairs. Yep, that's it. Now, the tough question goes to Gracie. What is your domain?
0, 1, 2.
Oh, that wasn't too bad. All right, range. Anna Grace.
7, 9, 16.
Okay. Is this a function? Raise your hand if you say yes. Yes, it's a function. Just raise your hand. Keep your hand down if you say no. And raise it high, guys. Don't. I think it. No, it is or it isn't. Is that a hand? Nelson? Okay, all right. Yeah, don't be afraid. Don't be shy. All your friends are doing it. Okay. All of you said it's a function. So Josiah needs to tell me why it's a function.
0 puts out 7.
Uh-huh.
1 puts out 7.
Oh.
They put out 1, 0 has its own, and 1 has its own.
You mean this input gives off exactly one output, and this input gives exactly one output, and then those two are fine. Yep, it's a function. Is that hard, guys? No, this is easy. As long as you keep the definition straight. Let's see here. Let's do these right here. I'll put the braces here. 0, 9. 0, 9. 0, 7. 2, 9, 3, 16. 2, 9, and 3, 16. So slightly different, but pretty much the same, except for one big fat thing. Okay, ready? I'm going to give you a shotgun question approach. Ready? Olivia, relation or not?
It is.
It is a relation. Ellie, why?
Because they're ordered.
Ordered pairs. Is this a relation, Matthew?
Yes.
Why is it a relation, Alex?
Because it's a second ordered number.
What's the domain, Will?
0 to 3.
0, 2, 3. Drew, what's the range?
9, 7, 16. 7, 9, 16.
Thank you. Henry, is this a relation?
Yes.
Sophie, why is it a relation?
Because they're ordered pairs.
Nelson, is it a relation?
Yes.
Why, Elijah?
It's in ordered pairs.
William, is it a function?
No.
Why isn't it a function, Avery?
Because 0 has 9 and 7 and can only
Good. What does this input value of 0 give off? It gives off
Numbers.
2 numbers, not a function. Not a function.
What if it was like 0, 3, 0, 3?
That's a great question. Let's say, how about this? This was 0, 9, 0, 9. So they're the same thing. I'm going to switch it up. Okay, if it was 0, 9, 0, 9, does every input value give off exactly one output value? Yeah. So it would have changed it to a function.
Okay.
Yes.
How do you find the like little number?
Oh, we're going to get to that in just a bit. Actually, we're going to do that this afternoon. You want to find the rules? That's a great question. You will find the rules. Okay. Ordered pairs are nice, but I like my circle mappings as well. Or my mappings, I guess I'll call them again. All right, we have A, B, C, D. A, B, C, D. And then we have E, F. E and F. Okay, so domain is on the left, range is on the right. And that doesn't give you enough. Well, I'm going to ask a trick question. Michelle, is that a relation? You're kind of hesitating. Why? You don't like the circle? I don't either. Can't stand the ovals. They're weird circles. Like smashed circles. Who thought of that? Okay, anyway. Can someone give me a definitive answer? Is this a relation? Yes or no? Jack Hart.
No.
Wait, why? Why?
Because there's no lines connecting them to make the pairs.
There's no pairs. No pairs. Now, if I did this, then B to E, and C to E, and D to F. Okay. Now we have ordered pairs A, E, B, E, C, E, D, F. Those are my ordered pairs. Good. All right. Is this a relation?
Yes.
Yes. Is it a function, Darius?
No,
No. Why not?
because E has 3 separate things.
E has different things coming to it. Gracie?
I think it is.
Whoa, debate time. I love it. All right. Who thinks it is a function? Who thinks it is not a function? All right, good. We have both sides. Good. All right, Nelson, you say it's not. Why not?
That's 3 E's.
It has 3 E's right here, like A, E, B, E, C, E.
Well,
Oh,
Yeah, I just raised my hand.
all right, cool. Yeah, that's the. Yeah. Who says it is a function? And Alex, why do you think it's a function?
Because A has 1, B has 1, C has 1, and D has 1.
Does every input value give off exactly one output?
Yes. And it's the same number, so it can work.
Yeah, just like it was 0, 9, 0, 9, 1, 9. It's allowed to happen. Yes?
If you like flip EF to the left side and ABCD to the right side, would it be not a function?
Because E, if it was flipped, would give off 3 separate values, and that's not exactly one value. Right? And I keep going back to my definition. So this is a function. How many of you are like, I get how to do a function? I get how to determine a function. Ultimate test, guys. Oh, you wish. You're going to wish you had homework after this problem. All right, this is what I want you to do. I want you to sketch this graph. So it doesn't have to be perfect, but don't worry. By the way, when we get to actually graphing these, I don't want to say the keyword, these shapes, you are going to do it perfectly. But today, just take it easy, kind of do your little artistic sketches, and
We're not perfect.
What was the word you didn't want to say?
if I gave it, if I said it, I'd give it away.
That's okay.
That's all right. Okay. Here's what I want to go over, guys, because yesterday I didn't really go over it too well, and I apologize. Let's look at the domain and range real quick, and then we'll go to function or not. Okay. Domain, what does that refer to? All the x values, right? And which one of these refers to the x values? The horizontal, right? This horizontal number line. Okay. Now, looking at this graph, okay, it's like a little U, but it keeps going infinitely, and it'll keep going infinitely forever and ever and ever. Are there any boundaries for the x values? Like, can x not be something? Or let me say this in a positive way. Well, I can't actually. Is there any value? Is there any x?
The answer is
Yes, x. I'm just going to give it to you. X can be anything. Can x be 1 on this graph? Can you get like 1, 1 here? Can x be 10?
yes.
Yeah, somewhere up there, x is 10. Can x be 100?
Yes.
Yeah, eventually it's going to go way up there. Can x be 1 million? Okay, can it be negative 1 million? Yeah. Is there any boundary on x?
No.
No. So x, for the domain, x is any number such that x is,
All real numbers.
Oh, we have to put set builder.
because it won't always be this friendly. And that's algebra 2. You're going to get it where you can be any integer, or it could be any whole number. So you got to write set builder. So set builder comes back, and set builder's angry at you guys for doing so well on that test. I mean, I didn't grade it yet. Did I say anything?
Mr. Ray, can we just put D is equal to, and then brackets, all real numbers at bracket, now X, such that X.
So you don't want to write that?
No.
Okay. Yes, sir. You won't get them today. Yes, sorry. I made the key, and I have one who still needs to take it. Okay. The range, though, I'm looking at the range now. The range refers to what values? The y values. So it's already going to be y such that. Okay. So look at the y-axis. Okay. Is there anything y cannot be? Is there anything you notice that y cannot be?
Negative.
It can't be anything negative. That graph does not even go into this territory here. But it can be anything, and this really starts at the origin. Anything greater than?
0.
Okay, greater than, and I have a closed circle here. So greater than or equal to 0. So y can be greater than or equal to 0. That's your range. That's all you're saying. Yes. Right? Could y be 7?
Yes.
Can it be 1,000?
Yes.
Can it be negative 5?
No.
Can it be negative 100? Can it go anywhere in this negative direction? No. So those are your boundaries. And the boundaries mean more as we get more restrictive with our graphs. Okay, you guys good on that?
Yep.
Okay, and then, whoa. I got my domain, I got my range. Is it a function or not? Go.
Wait.
Yeah, sorry. Oh, do you want some numbers?
No, I don't need numbers.
Okay, good. Yeah, you don't need numbers, actually. You're right. Function or not? Let's do this, guys. I want you to put your heads down. Close your eyes. Yeah, please don't look up. So you're thinking of that graph, and I'm going to ask the question, is it a function or not? Okay, so close your eyes, put your heads down. Thumbs up. Okay, good. Wow, 2 of you did it. Okay, now many of you did it.
What are we supposed to do? Wait.
I'm coming around to touch your thumb, and then you're going to try to guess who it was. All right, heads up. Oh, wrong. Oh, I'm so sorry. No. Put your heads down. Don't put your thumbs up. Close your eyes. Oh, man, I had, as an elementary student, I remember playing that game, and I would never guess who it was. Never. I never came up here unless the teacher picked me to come up here. Don't look up. Don't look up, guys. No, stop. Okay. If you think that graph, you're like, what graph? I forgot what we're talking about. If you think that graph is a function, raise your hand. Okay, put your hands down. If you think that graph was not a function, raise your hand. All right, put your hands down. All right, you can put your heads up, open your eyes. Can anyone guess who got you? Okay.
It's a function.
All right. It is one or the other. It is going to be either a function or not a function. And I had a split. So that was good.
It's a function. It's an N. F.
What is that? You can put function on.
Oh, so I'm not done. All right. It is a function. Oh, I heard someone say it. Dare we bring that up? Do you guys remember your vertical line test?
Oh, yeah.
Vertical line test. Okay.
I saw it highlighted right there.
Yeah, so it's in your book. I used to have a cool ruler, but it got broken.
Candy time.
IXL, yeah. IXL will return. All right, guys. Here's my vertical line test. All right, a vertical line is up and down vertically. Okay. What I do is I run it through the graph, and is there any? Tell me to stop when this vertical line hits more than 1 point on this graph. So tell me when it hits more than 1 point. More than 1 point. Okay. Did it ever hit more than 1 point?
No.
So it passed the vertical line test. It is a function. Now you're like, so first we were dealing with the numbers. Now we're dealing with this imaginary vertical line. Okay, ready? We're going to make up some values here. 1, 2, 3, 4 on the negative, right? 1, 2, 3, 4. 1, 2, 3, 4. Okay, let's just pick a couple points. I'm going to pick this point right here, and like this point right here, and this point right here, and this point right here. Okay, what's the order pair for this point right here? I think it's negative 2, 1. About. It's not perfect. Negative 2, 1. What's this point right here? Negative 3. 3. Negative 3. 3. What's this point right here?
Wait, what does that mean? Negative 3, negative 3?
No. So you went negative 3, up 3. So it's positive. 2, 2. And what's this point? 3, 4. Which is totally not the parabola, but it still brings a point. Those 4 points that I picked, and I could have picked an infinite number of them, but they're just whole number points or integer points. Is there ever a time where one input value gives off 2 output values?
Never.
No, it never will happen. It follows the same rules we already looked at. It's a function. So the vertical line test is nice. By the way, if you have the graph, it is very easy to tell whether it's a function or not, right? Because all you have to do is run that line test, pass or fail, and you get your answer. Okay.
The line is straight up.
That was
They could
it.
hit more points.
Okay, yeah. So if you had, I'm going to give you 2 examples. So if you had, for example, this, okay, does this pass the vertical line test?
Yes.
No.
Yes.
So whether it passes does this vertical line ever hit more than 1 point at a time?
Yes.
No, never. So it's a function. All right, and then I think you guys are talking about this one. If you had a vertical line graphed, is there ever going to be a point where this line hits more than 1 point? Like it hits, oh,
Dude, no way.
I knew this had more power.
Race to a ball top.
Not a function. Oh, actually, you know what's cool? Can I teach you about geometry with this little pencil or this little? Okay, you know why it did that? Do you know why it did that?
Why?
Okay, when I touch the board with my hand, right, it does that eraser. Okay, but when I do 1 point, it just writes. Okay, you're like 1 point, it's following my point, and then it erases. But when I put a whole thing, it's a big eraser. Now, why did it do Why did it do a big eraser with just a ruler? Raise your hand. There isn't.
Mr. I got you.
Okay, I'm gonna go with William.
Because there was like an infinite number of points.
There's an infinite number of points that make up this ruler, like literally, like whoa.
Not infinite because it stops. That was
No, but it goes. It's trying to hit the range of them.
That was way larger.
So here's infinite number of points. Infinite number.
That was so much.
Now use just a quarter of it.
That could erase the board in 3 swipes.
The power of the ruler. The power of the point.
Just right, do it.
Do it, giant.
Yeah, do it. Oh, it worked.
Don't say anything about the size of that, please. Okay. I wish. All right, here we go, guys. I need 25 of you getting this right. 25 of you. Oh, wait.
There's only 24 of us.
I'll count.
We have one for you, Ray. You better not mess up.
If you mess up on purpose.
I will not mess up on purpose. Okay. Do not call out the answer. Just write it on your paper, but draw this graph because you'll have it in your notes.
Mr. Ray, have you gotten another 10 out of 10 yet on your quiz?
I haven't taken another one, but I'm reading. So this is what happened. I was reading my chapter last night in my recliner, and when I got to like 2/3 of the way,
Oh, sweet.
I was out. I'm like, 1, 2, 3. I'm out. Knocked out cold. Thank you. So I didn't get to take it last night. I will take it tonight, unless I knock out again.
Will it be a 90 and be a 9 out of 10?
I have 2 more quizzes. I've gotten an 88 average on my quizzes. I've gotten one perfect score.
A with a B.
One perfect score, and all of them have been 9s or 8s. So 90s or 80s. So guys, no, I don't think I can do it. Oh.
Like -1.
Okay, ready? Here we go.
If you get one right.
Oh, this is easy.
Oh,
Shh! Don't call it out. Just write it. Just write it down.
C for Clemson.
It's possible. Or an E for 49ers. Okay. Oh, come on, guys. I'll get you championship shirts later.
Oh, my goodness.
I've gotten over the Warriors. I'm still a Warriors fan, guys. I can't wait to go to that new arena. Can't wait to see another banner raised, but that's going to take a little time. As in this year. I'm calling it. Calling it.
Hey, I'm calling Clemson winning next. Beating South Carolina by 100. Didn't have that on tomorrow.
Oh, you're getting some people upset. Hey, Will, you're getting personal, buddy. All right. The answer is... Hold on, let me write it down because it's more dramatic. Hold on. I'll tell you when I'm done.
Great, I got it right. Still got it right. Wait, what?
Oh, I did okay.
He's really basic.
I think I meant to say... Come on.
Undo.
It is not a function. It fails the test. All right, 25 of you.
Wait.
So raise your hand if you got it. Yeah, I got it. I almost missed it because I wrote it wrong.
It failed the vertical line test.
Who's just really good at this? Like, Mr. A, you give me any graph, I got it.
I don't want to be on the my hands.
Ooh, oh, Jack Angel, come on down. Jack, I have a task for you. It's gonna actually be tough. You guys can. Think of it.
Draw any line or shape. I read the alert.
Yes, that is part of it. You know what I'm asking for? Yeah. All right. I only want 15 of you to get this one right. 15 or more is good. If 15 or fewer, Jack gets something. All right, here we go.
Do like the easiest one.
Yeah, Jack, do the easiest one. Oh, that's a nice one. That's actually a graph. That is a graph, and that's acceptable. Yeah, you can draw, you just sketch it, doesn't have to be perfect, but sketch that graph. That is an actual graph, I'll tell you which one it is, but you have to tell me function or not. So 15 of you or more have to get it. That's good, Jack. That's kind of what I wanted. Sorry? Is function or not a function? Okay, here we go, guys. It's okay. It is the opposite of not a function. You're like, huh? It is a function. Does it pass the vertical line test? All right, how many of you said function? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, you got it. Okay, thank you, Jack. This is, oh. All right, this is a type of function. Actually, if I think it's going to be like y equals negative absolute value of x plus like 5. If this were 5 right here, that's what it would have been. That is actually an equation. You will be dealing with it. The main thing is this. If you have an absolute value, it's going to be shaped like a V. Either it's an upside down V or a right side up V. Oh, man. We didn't even get the function rules. What? Yeah, no homework yet. Okay, bye.